So by now, I hope you guys have a good grip on the word state. Right? State variable, state. State is nothing but particular value that the state variables pick up. So we know that any given system need not have the same state for a very long time. It can change rapidly or slowly or whatever it is, but it will change. It's not fixed. For example, over here, we have a pressure volume scenario, right? So the pressure, say it starts over here, pressure volume scenario is over here, like this is 2.6, 0.5, right? That's the coordinate over here. And it ends up with 3, 0.2, for example. So there is a change. It has moved from point A to point B. The path it takes, the state, the values take, the path when we plot it, that path is known as process. The path connecting two states is your process. Cyclic process is a scenario wherein you start at a point, you move, and you come back to the same point. That is your cyclic process. Okay, cyclic process is a scenario wherein you start at a point, you take up many paths, and you come back to the same point. That is your cyclic process. So process is the path connecting two states. Cyclic process is the path wherein, actually not only the path, it is a scenario wherein you take up any path, but you come back to the same point. The initial and the final state are identical. So that is a cyclic process. There are different types of processes that we need to know in this chapter. Starting with adiabatic. Adiabatic process is wherein you have no heat or mass transfer between the system and the surrounding. Okay. So we will be talking about all of this in detail. This is just an overview. So just keep this in mind. Isothermal. Iso means same. Thermal means to do with temperature. So temperature remains constant. In this process, the temperature remains constant. This happens by very slow process and good thermal contact. Again, if you don't understand this, it's okay. Just a small note so that you guys have a basic idea when we actually dive deep into the entire thing. Isobaric. Baric has to do with pressure. Iso is same. So pressure remains same. So this is achieved by slow expansion on compression with movable piston. All of this is needed. We'll be making use of it. So here again, we are looking at pressure volume graph, and it's a flat line. It's parallel to x-axis. Isochronic, or not chronic. Okay, I can't read that. Isovolumetric. So volume remains constant. So you can see the graph over here. For any pressure, the volume remains the same. Cooker, basically. Right? Another way to classify the process is static, quasi-static, and non-quasi-static. Okay, static means what? The situation is static. What does static mean? Correct, no change. What is quasi? Quasi is slow. Almost stationary. Quasi is almost stationary. Quasi-static means almost stationary. Indirectly, we are talking about a very slow process. Non-quasi-static is fast, rapid. System remains in internal equilibrium at each stage. Sorry, I'm reading quasi-static. System remains in internal equilibrium at each stage. Thermodynamic variables, the pressure, volume, and temperature, they are well defined throughout. You know what is happening at what point of time. For this pressure, what is the temperature, what is the volume, you know that. While in non-quasi-static, it is sudden. You take a balloon, you make a hole, you blast it basically. What happens? It is non-quasi-static. It's very rapid. We don't know exactly what is the pressure, volume, and temperature, and so on and so forth. Things are not easily measurable. Okay, that's another classification that we need to know of. And finally, we have process equation. So basically, you know what is an equation. Process equation is an equation, mathematical way of describing what is happening. Okay, guys. A process equation tells you the relationship between variables when one thing is fixed. Okay, so let me give an example. Given volume is constant, what is happening with the pressure and temperature? Right? Which describes that equation that describes that is your process equation. So process equation helps plot, it helps plot your pressure volume graphs that we saw. So similarly, there are other graphs that we'll be going through. So let me not dive in deep into that. Okay, yes, there are quite a few terms that we have learned from past few videos. All of those are important. All of those will be used in quite a few places, especially in thermodynamics. Okay, so everything has to be known. So everything is related. Pause, take a note of everything, and see to that you have a good basic understanding. All your questions and all your doubts will be cleared as and when we use it in detail, right? We'll be studying all of this in detail. Actually, using it in detail. Using it actually in detail does not make sense.